This is the Catch-Up Network.
Imagine machines that learn and adapt like humans, transforming industries at unprecedented speeds. In this insightful exploration of machine learning, you'll discover how algorithms leverage data to predict outcomes, understand customer behavior, and even drive autonomous vehicles. Get ready to unlock the foundations of a technology that is reshaping our future.
Hey, what's up,
The
everyone?
initial greeting establishes a conversational tone, inviting viewers into a complex discussion about machine learning. Such introductions are critical in educational mediums, as they foster engagement and create a connection with the audience. This approach is fundamental in online learning environments, where the effectiveness of communication shapes the learner's experience and receptivity to subsequent information.
My name is Luv Aggarwal, and I'm a data platform solution engineer for IBM.
Here, the speaker, a data platform solution engineer from IBM, emphasizes the growing significance of machine learning in both business and technology sectors. This acknowledgement underlines the paradigm shift towards data-driven decision-making in contemporary organizations. As enterprises increasingly adopt machine learning for strategic advantages, understanding its implications on operational efficiency and innovation becomes essential for professionals across various industries.
Machine learning. There's no doubt that this is an incredibly hot topic with significant interest from both business professionals as well as technologists. So let's talk about what machine learning, or ML, is. So before we get too far into the details, I want to take a minute to talk about some terms that are often used interchangeably, but have certain differences. Terms like artificial intelligence, machine learning, and even deep learning. So at the highest level, AI is defined as leveraging computers or machines to mimic the problem-solving and the decision-making capabilities of the human mind. And machine learning is a subset within AI that's more focused on the use of various self-learning algorithms that derive knowledge from data in order to predict outcomes. And then finally, deep learning is a further subset within even machine learning. And deep learning is often thought of as scalable machine learning because it automates a lot of the feature extraction process away and eliminates some of the human intervention involved to enable the use of some really, really big data sets. But for today, we'll just focus on machine learning.
This segment meticulously delineates the distinctions between artificial intelligence, AI, machine learning, ML, and deep learning. By framing machine learning as a subset of AI, the speaker articulates the layered structure of these technologies. Such clarity is essential in educational contexts, as misconceptions often hinder effective application. Furthermore, the mention of deep learning as a scalable machine learning encapsulates the ongoing trends in handling large data sets, highlighting the technological advancements that facilitate more autonomous decision-making in AI systems.
Get rid of the other two and dive one level deeper and talk about the different types of machine learning. Okay, so the first type that we have is called supervised learning. And this is when we use labeled data sets to train algorithms to classify data or predict outcomes. And when I say labeled, I mean that the rows in the data set are labeled, tagged, or classified in some interesting way that tells us something about that data. So it could be a yes or a no, or it could be a particular category of some different attribute. Okay, so how do we apply supervised machine learning techniques? Well, this really depends on your particular use case. We could be using a classification model which recognizes and groups ideas or objects into predefined categories. An example of this in the real world is with customer retention. So if you're in the business of managing customers, one of your goals is typically minimizing and identifying customer churn, right? Which are customers that no longer buy a particular product or service. And we want to avoid churn because it's almost always more costly to acquire a new customer than it is to retain an existing one, right? So if we have historical data for the customer, like their activity, whether they churned or not, right, we can build a classification model using supervised machine learning and our labeled data set that will help us identify customers that are about to churn and then allow us to take action to retain.
In this segment, the discussion on supervised learning pivots to practical applications, particularly in customer churn analysis. The strategic insight into minimizing customer turnover through classification models speaks to a critical aspect of customer relationship management. The emphasis on the cost effectiveness of retaining customers versus acquiring new ones underscores the financial implications of machine learning applications. This perspective resonates strongly within the context of modern business strategies, where data-driven insights are paramount for sustaining competitive advantages in saturated markets.
Okay, so the other type of supervised learning is regression. Now, this is when we build an equation using various input values with their specific weights determined by the overall value of their impact on the outcome. And we use these to generate an estimate for an output value. So let me give you another example here. So airlines rely heavily on machine learning, and they use regression techniques to accurately predict how much they should be charging for a particular flight, right? So they use various input factors like, days before departure, the day of the week, the departure, the destination, to use these to predict an accurate dollar value for how much they should be charging for a specific flight that will maximize their revenue. Okay, so now let's move on to the second type of machine learning, which is unsupervised learning. Okay, so this is when we use machine learning algorithms to analyze and cluster unlabeled data sets. And this method helps us discover hidden patterns or groupings without the need for human intervention, right? So we're using unlabeled data here. So again, let's talk about the different techniques for unsupervised learning. One method is clustering. And a real-world example of this is when organizations try to do customer segmentation, right? So when businesses try to do effective marketing, it's really critical that they really understand who their customers are, right? So that they can connect with them in the most relevant way. And oftentimes, it's not obvious or clear how certain customers are similar to or different from one another, right? And clustering algorithms can help take into account a variety of information on the customer, like their purchase history, their social media activity or website activity. Could be their geography, and much more, to group similar customers into buckets so that we can send them more relevant offers, provide them better customer service, and be more targeted with our marketing efforts. Okay, and the last point I want to touch on for unsupervised learning is called dimensionality reduction. So we won't discuss this in detail in this video, but this refers to techniques that reduce the number of input variables in a data set, so we don't let some redundant parameters over-represent the impact on the outcome. Okay, so the last type of machine learning I want to talk about today is called reinforcement learning. Now, this is a form of semi-supervised learning where we typically have an agent or system take actions in an environment. Now, the environment will then either reward the agent for correct moves or punish it for incorrect moves, right? And through many iterations of this, we can teach a system a particular task. Now, a great example of this method in the real world is with self-driving cars. So autonomous driving has several factors, right? There's the speed limit, there are drivable zones, there are collisions, and so on. So we can use forms of reinforcement learning to teach a system how to drive by avoiding collisions, following the speed limit, and so on. Okay, so we covered many topics today, but we've barely scratched the surface of each one. If you found any one particular aspect of machine learning interesting, I encourage you to dive deeper and learn more about it. And if you want to know what are some of the common machine learning algorithms and how to leverage them in data science, please check out some of the links in the description. Thank you. If you have questions, please drop us a line below. And if you want to see more videos like this in the future, please like and subscribe. And don't forget, you can grow your skills and earn a badge with IBM Cloud Labs, which are free, browser-based, interactive Kubernetes labs.
This concluding segment delves into unsupervised learning and reinforcement learning, emphasizing their growing relevance across various domains. The exploration of clustering for customer segmentation is particularly insightful, showcasing how businesses can leverage unlabeled data to uncover hidden patterns. The discussion of reinforcement learning, especially in the context of self-driving cars, highlights the innovative potentials of machine learning technologies. This intersection of AI and everyday applications illustrates how machine learning not only transforms industrial practices, but also shapes societal norms and operational methodologies, warranting a deeper appreciation and understanding of these technologies. Thanks for watching. And of course, if you like this video, don't forget to like and subscribe below. But don't stop there. Start making videos like this for your own channel. Click the link in our bio to get started.
This is the Catch-Up Network.